Good afternoon, everybody. Thank you for joining us this afternoon for the Surgical Holdings Academy presentation, Containers, Circular Economy or False Economy. I apologise because I've got a bit of a croaky throat, but I will do my best to present. I might have to just stop for a bit of water every now and then. Brief introduction. Surgical Holdings, for those that don't know, it's a company based in Southend. We're part of the Stiller Group, and we're a manufacturer of surgical instruments and repair of instruments. We also distribute a number of key product lines, including the Bahadir container range. Our academy has been very successful over the last few years. We have presented on a number of different subjects across the medical device landscape, and we intend to do more this year, so we'll make sure we put out some more information on this. We also will have another live event which we've done this year as well, so look out for that. It's likely to be a London venue, so we'll share all the information in due course. You'll get a certificate of attendance that should come through after attending the webinar, and if not, we will arrange that. Just to say, we're really pleased. We've got over 100 people registered. This will be recorded, so anybody that hasn't had time to see it, we can share the recording in a follow-up mail afterwards. Questions along the way, there's the Q&A and there's also the chat, so feel free to chuck stuff in there and I'll try and pick them up as we go along. Okay. So this is the areas that we're going to cover today. So we're going to look at what a container actually is, how it's manufactured, history around that, the workflow of containers, how that actually works within a hospital, design challenges, regulation, obviously a key important subject nowadays, and a number of different areas, including sustainability and some maintenance at the end there as well. Okay, to kick us off, what are actually sterilisation containers? Well, they are rigid tins or boxes, and they are usually manufactured from aluminium, most commonly at the moment, and also stainless steel. They're of course designed to safely hold and transport surgical instruments during sterilisation, transport as mentioned, and indeed storage. And this is what generally they look like, the probably the most common designs out there that you'll see on your shelves in your hospitals. Height wise, they come in a variety of different heights depending on the set and what's going in them. More commonly, we see the size of probably 150 millimeters and 200 millimeters. There are also different widths. Here you can see that you've got the full size, which is 585 by 280 mil. That is pretty much the most common, which would fit around about a sort of standard sort of dim basket, the most common dim baskets. There are other sizes as well, half size for obviously smaller baskets and smaller sets. And there are some longer designs now as well, and these are generally to accommodate things like Da Vinci robot arms. The dimensions are quite relevant when you're looking at containers and moving to containers if it's something you're considering. And the reason being is, of course, you're restricted. The container is the size that it is. If you have a set that won't fit those in that size basket, you might be used to having a double dim basket, then it's likely that you're going to have to duplicate those and have double the amount of the baskets that you'll need, or double the amount of containers that you'll need. There's also restrictions around loading. So here you can see in this table on the right that there's a weight guidance that you are not that you should not exceed, obviously from a health safety perspective for your colleagues who are handling these on a day-to-day basis. So for instance, if we take one of the more popular sizes, you're looking at something like 585 280 by 190 there. That's around just over 7.5 kilos. So it's not actually particularly heavy when you think about loading up lots of surgical instruments. Some sets that might have sort of upwards of like 100 instruments or so in them. So of course, that's a big consideration. They come in lots of different colors. So here you can see some of the examples of those colors. And that's actually obviously a really great benefit of the aluminium. You're able to anodize in different colors. And that allows you to potentially distinguish between different sets or different departments in the hospitals. Also, it's quite a catching thing, and rather than just a simple grey lid, but obviously it's very popular for different hospitals to have different colours associated with their sets. So another element around the design itself. So in the common containers that you see, generally speaking, you'll have this sort of lid, and this has a filter in the lid. And how it works, how do the basics of the steam sterilisation with the container. So during sterilisation, under pressure from the steam pushes through the filter, and after the system cools and the pressure reverses and the barrier is created. So obviously you've got your filter in there, which creates that barrier. It's an interwoven filter that prevents microbes from passing. And of course you have gaskets around the lid of that filter holder, and indeed the lid itself of the container. So you can see there an example of the silicone gasket. Um, and that should sit snugly around the lid of the container. And if I just click on here, you can see an exploded view of the container lid itself. You can see the gaskets that sit around the lid here. This is generally silicone, and indeed hold the filter plate in place. Just quickly to go back to mention filters. I've mentioned the typical setup here. This is a disposable filter, and this is what we generally see the most of throughout hospitals in the UK. That's like a paper filter. There are other varieties out there, so there's reusable filters such as PTFE as well. Consumables to consider with containers. So obviously you might think containers, and we're thinking around sustainability, but there are consumables as well. So you've got labels, you've got the safety security seals, obviously to click on to ensure they're not tampered with when once the containers are obviously ready to go to theatres. So obviously all these things are for consideration. If you notice on some of the labels, they'll have sterilisation indicators, and indeed they might have on the security tags. That's so you know that they've been reprocessed and sterilised. What regulations are relevant? Well, you have HGMO 101, which of course is key in the UK. 11607, packaging validation for sterility assurance, sorry, and there's also an American standard AAMI ST79, so biological testing guidance for rigid containers. And these are all relevant when you're handling containers in sterile departments, and of course also when they're being manufactured. And a bit more on that now. So what sort of things are we testing when we're manufacturing containers and testing and validating them? Well, you're looking at things like pressure decay to detect air leaks. Obviously, that is not something you want when you've got a container. You hope that it's sealed and it won't leak air and potentially bugs. Sterilant penetration and microbial barrier integrity. So that's as directed by 11607. Dye penetration tests. Of course, routine inspection of gaskets and filter mounts, and I'm going to give you a bit of guidance on that later on. And also we have the event-related studies, which are obviously key when you're manufacturing things like the drop tests. We know that these when we're handling these in sterile services departments or as indeed potentially in theatres, that they may get dropped. So we have to test to ensure that some of these event-related issues are okay and are okay for you to carry on using your container. Mechanical checks, visual checks, and accelerated aging. Accelerated and real-time aging is very key when you're looking at the shelf life of your container. In the UK, it's 12 months, so that's the acceptable level of time generally that the container needs to have shelf life-wise. However, you'll see a lot of European containers that only have half of that. So that's something really key to look at if you're looking at investing in containers, to make sure that you're not going to have a problem with your notified body if on the IFU it says they've only been validated to 6 months. So 12 months is key. Okay. So where are the containers manufactured? Typically Germany. So very obviously famous. We have Esculap containers, KLS Martin, also a famous producer of containers. But also Turkey. There are a few established OEM manufacturers, and they also have their own brands and exports to the UK. One of those indeed is Bahadir that we work with. So very high quality. reliable manufacturing and quality. And and then there are obviously other lower cost options such as China, Pakistan, and India, with variable quality options there. The UK I'm going to mention because we're innovating on things like refurbishment and repair of containers, but also add-ons to things like RFID for tracking. I've mentioned earlier the materials for the containers themselves. So typically anodized aluminium, very popular, the most popular. Why is it popular? Because they're light. We talk about putting what you're going to have to load into that container. Obviously, it's an extra metal vessel that you're going to have as well as your dim basket. So aluminium is light in itself. It's got good heat conductivity, obviously very important for heating it up quickly and also cooling. And of course, as I've mentioned, they can be color coded. Stainless steel, on the other hand, also a very good option for containers, extremely durable, more durable than aluminium. However, good chemical resistance, however, much heavier. And that is also something, obviously, when you're thinking about options, what can you, with a container that is aluminium, you're likely to be able to get more in because obviously you've got more weight with the stainless steel container. I've just got a short video here just to give you an example of how a container is made from start to finish. Hopefully this will work okay. Okay, so hopefully you can see there how obviously what a complex process it is to manufacture a container, and you've got such a wide range of we're going again, sorry, such a wide range of different processes there, from CNC machining for the vents and profiles, drawing the aluminium from sheets and shaping the base and lid, obviously the anodizing, but also testing things like the thickness of the anodizing, assembly of the gasket. So hopefully now gives you a bit more insight when you look at what seems to be a relatively simple product that you're using as to what's going in it to manufacture it. So we talked about the common containers that you're seeing out there, the aluminium with the paper filters. Emerging technologies, there are some technologies coming out there. So things like long-term filters. I mentioned the PTFE filters. Some of these are validated for up to sort of 5,000 uses. There are also valve systems. I'm going to show you an image in a minute of the type of valve system that you might have on a more recent innovative container. Smart containers with electromagnetic sealing, not something I've seen personally, but I've certainly started to read about this. Advanced drying systems and RFID and smart sensors. So these are things that to look out for as the years go by in terms of the innovations and where containers might be going. As I've mentioned, the valve system. So this is inspired by Louis Pasteur's famous research. So we have a valve system that opens during sterilization and then closes. And you can see here what's described as the sort of the tortuous path, which prevents the microbes from traveling through. So obviously this complex labyrinth, the microbes are blocked out. There's no direct path, which means the microbes can't be carried in. So it's actually a very simple system, but means that you don't then need a paper filter or a PTFE filter that you've got to replace. You just have this barrier valve system that is then means that you have obviously the validation for a particular amount of cycles. So after obviously they dry after sterilization, meaning the microbes then can't crawl through as well. Any questions around these as we go along, please chuck it in the chat and I'll pick up at the end. So why are we talking about containers more at the moment? Well, they're drivers for change around sterilisation and looking at ways we can potentially be more sustainable. So there's a Department of Health project called Design for Life that Surgical Holdings have been involved with. And part of that has been looking at things like waste from wraps. And yeah, obviously commonly in the UK, there's a lot of tray wrap that's used. So that is something that's been highlighted. And looking at some research that I've come across when I've been researching for this presentation, De Bruyn found in 2022 that containers reduce carbon by 85% versus wrap, which is obviously quite considerable. We're looking at the moving from a linear economy model with the wrap from taking materials, manufacturing, using, and then disposing to a circular economy model where we're choosing raw materials for products, new innovative products that can be obviously then designed smartly, produced, and they'll then last and can be reused, potentially be repaired, and then eventually recycled, which obviously aluminium works well for with its containers. Another driver for change, tray wrap tears. Some information here, a single centre in the UK and south of England over 30 weeks had 601 instrument sets rejected for wrapping defects. So the highest being 13 same day case cancellations, most being holes and tears. Obviously, we don't have any further background to this, but obviously this is substantial. This is causing disruption to the surgeries on a daily basis, and this is something that potentially that containers could help out with. However, we've got to realise that they're not a magic box. This isn't something that we just put a lid on and it does all the magic. So just be aware that there are caveats as well with containers and important things to consider. Let's look at the workflow now around the container usage and how they go through the CSSD and make their way to theatre. So first of all, preparation, of course, as we would, inspecting instruments, cleaning, assembling, placing them inside the sterilisation container. I'm saying with a new disposable paper filter here, as that's generally our experience. Closing the container and sealing it, loading it into the autoclave. Some containers can be used in low temp now. This is important we've seen recently for some of the Da Vinci scopes. Steam penetrates through the paper filter. Heat and pressure sterilise the instruments. And in the cooling phase, the filter prevents recontamination. So post-sterilisation handling, containers cool, they're checked and stored. Obviously, we want to make sure the integrity is there. So looking at things like the seal, the filter, the gasket, and verifying that. And then obviously transporting to theatres. So the containers are moved securely to the OR. Often they'll be in a big movable trolley, for want of a better word, that might be locked. So the containers move securely, tamper evident locks to confirm the sterility, as I showed you earlier, the plastic locks that you have, which are generally disposable. They'll be used, so the scrub team will verify that seal is intact. The container will be opened and instruments presented to the surgeon. Then obviously the empty container is then returned to the CSSD, and the process there will then repeat for the next cycle. So, as part of my research for this presentation, I spoke with a user of both containers and tray wrap, and just to get their thoughts and what their reflections are as they work in a hospital that is very high usage. The photo here, I can assure you, they look like they're some sort of victim where they're blurred out. So I can assure you that that isn't the case. They weren't held against their will, but they came up with some great insight. So what they said was there's big restrictions for containers in terms of capacity. That's something we discussed earlier about potentially needing to decant double DINs into 2 trays. So that's something to consider. Therefore, they questioned if there is real life sustainability savings, because if we're having to then have two baskets, 2 containers, then that duplicates the need for double the amount of from a capacity perspective. They also needed to have a large dedicated storage area and more racking, um, and concerns around ongoing validation. And I think what the concerns were with tray wrap, if you can inspect it, if you see a hole, then you will know that potentially there's an issue there, with the sterility, whereas that might be an unknown with a container itself. So obviously that's a challenge. Trade tears were also not a big deal for them. They said generally in their hospitals, unlike the hospital I mentioned that earlier, that this wasn't a big thing, and that actually it was more of a surgeon-driven thing, and it was where surgeons have been used to containers in other hospitals, and it was just they felt that they would deem that that was the standard that they should have, but this wasn't a major thing for them in terms of tears. As I mentioned, demand was surgeon driven, but obviously just to reflect back really to the capacity side of things, and the challenges on that. Of course, that will also mean that potentially more washers will be needed, and that's something to think about. He did mention that they're good for off-site use, so this is something that's given assurance when you're sterilising off-site, and then trays are travelling around, having the instruments and containers obviously gives a good assurance there that that they're gonna maintain that the container will maintain the integrity of the sterile barrier. So let's look at microbarrier effectiveness now. So some research I looked at. So tray wrap showed a 0% contamination under challenge conditions. That's from Schaefer from 2015. And containers potentially had up to 87% contamination if aged or damaged. That was highlighted in that same research. So this is something that perhaps aligns with the concerns of my interviewee in the previous slide. Water leak test predicts container seal integrity, so that's something that is being used, is using a water test. And wraps generally are considered more consistent unless containers are well maintained. I'm going to show you some pictures later that challenge that and pose further questions. But I just want to reflect here around the testing. Obviously, it's been highlighted that there is this concern around once we seal a container, how do we know it's tested? Well, there are some new innovations out there, and I'm just going to share you a short video of one of those for testing containers and the integrity of the seal.
That's good. So it's very simple. Before you seal the container, so you have packed the instruments in there. Before you seal it and sterilize the instrument, you put the container in the test device, close the lid, press the start button. What we are doing now is we make a small vacuum inside of the container of 25 millibar. When we achieve that in the pressure, we close all the valves and we stabilize the whole system. Then we start the measurement. And the measurement, we measure how much air is wanting to come into the container through the gasket. And that will be shown in a result on the screen, and as well with a very clear indication here with the green and the red
Thank you. So as you can see, this is an exciting innovation for testing containers, testing the unknown, as we're not entirely sure. And there's obviously the water test historically out there, but this is another option that is um, a test that is objectively looking at the container and testing that seal. Oh, sorry. Okay. I mentioned Design for Life earlier. There have been some pilot studies that have come out of Design for Life, the Department of Health project. One of those is to look at containers and again looking at potentially converting sites that are already using tray wrap. So Cardiff and Val was part of this pilot. So there was a pilot to assess this containers versus tray wrap. Waste generated 60,000 single-use wraps at a cost of nearly 150k, which is obviously huge. Cost savings as a result of this pilot. So they were 61,500 per annum. So obviously significant cost savings, and emissions saved of 4,000 kg per CO2. So that's nearly 6 times for an average household consumption of energy a year. So obviously significant savings there through that they've found as a result of this pilot. Some other considerations. Where staff were used to using tray wrap and obviously were very familiar with this, staff would have to be trained and trained on how to handle with containers, obviously how to lock them properly, how to inspect them. Cardiff have a capacity for an extra washer, so other sites may not have that. So if you're looking at potentially having to duplicate sets or split them out, then that's got to be consideration. Do you have the extra capacity? This was a large capital outlay, and so there's also thought around whether this could be handled through a managed service model. Um, and traceability, the container is part of that set now, so this is another thing that you have to maintain your traceability on the container itself. One thing I thought was that I don't think had been completed or was recommended to be completed with a usability study. So this is around unintended consequences. So this might be things like the effects of the extra weight on the staff, potentially noise of the containers themselves, their tins, do the handles rattle? So all of these things need to be play out. But what's been decided is they're going to look at a phased approach around to take over around 30-40% of their, or convert 30-40% of their sets to containers. From a cost effectiveness perspective, the containers, again, reflecting on research that's out there, rigid containers saved around €2 per cycle versus wrap. So that's obviously a significant saving and that cannot be ignored, and indeed has been highlighted by the Cardiff study. Real hospital return on investment, so 30,000 saved in $30,000 this was saved in year one, 233,000 saved over 10 years from the ROI from changing to containers. And actually the payback of using the containers started, and this was a 5,000 cycle container, so it started after cycle number 68 of the containers being used. So this is quick payback if you're looking at that investment. So yes, they have a higher upfront cost, but a lower long-term cost, and best life cycle value with regular use. One thing I would like to highlight that I pulled out of these studies, which obviously the results are favouring the containers, is that they did not measure the water and energy consumption, but they relied upon this information coming from the manufacturers of the containers. So this is obviously something that I think needs more work to look into this. So recommendations for checking the containers themselves. Obviously, as we mentioned, it becomes part of the set. Like an instrument, it also needs then maintenance and inspection considerations. So that's a vital importance if this is going to be a safe thing to use. So first of all, just to highlight anodizing. I struggled to find an acceptable photo of white powder on the internet, but I found one. So there we go. There's a photo of some white powder. And why am I showing white powder? Well, anodizing can easily damage through cleaning or the anodizing of the container itself, the aluminium anodizing, and that is effectively, as we saw in the video I showed you, it's a dipping process that essentially seals the container itself. Well, that anodized layer, the color, if you like, can be damaged. And then if that is damaged through harsh chemistries or chemistries that are deemed to be a too higher alkaline, you get this white powder. So this is something that we need to be aware of. If we see this, then And this is something we might want to bring up with the manufacturers of containers themselves. Just to mention briefly about that point again, obviously I mentioned about bringing up with the manufacturer of the containers. Obviously, this is generally comes about through being only when they're used outside of the parameters that are recommended by the IFU. So damaged containers. So these are some photos of the containers that were taken from hospital. So this is the sort of thing we see. We mentioned about um, how these containers are tested. Unfortunately, they definitely can't put up with this sort of thing. So you can see here, you should have a nice rounded edge, but this is what we've got, which is essentially a flat on one side of the container. So obviously it's unlikely that when that lid's closed, it will seal correctly. That's close up there. You can also see all the anodizing has come off of this container here. Got chunks out of the containers. Aluminium is a nice light material, so also fairly soft. So there's a chunk missing from this container here. We don't know really what the impact of that is, although I would say that if you showed the manufacturer that, they would say that that should be replaced and taken out of service. Again, dents here from where they've been dropped or knocked into each other. And then you've got also around the gasket. This has got a dent there, but this has affected the gasket. So obviously the gasket is providing that seal. And these are things that you need to look out for in your containers. If you've got anything like that, they should be taken out of service because that could impact obviously the integrity of the seal itself. Again, you've got an example of a split there in a seal or a gasket. More chunks are there. You can see silicone that's dug out there, and again that could potentially affect the seal. So as I mentioned, we should be treating containers like instruments. So the container should be on a preventative maintenance program. I was fairly shocked when we first put containers out in the marketplace, how little responsibility that the hospitals wanted to take, or really were aware that they needed to take after these containers had gone in. As you know, as I mentioned previously, like they're not a magic box. You can't just put them, start using containers and not look at them again. So they need to be on some sort of preventative program, looking for things like, as I showed you, if there's damage to the container itself, probably replacing things like the lids or being very cautious, particularly if there's any scratches or marks on them. How would that potentially affect the integrity? So inspect and handle with the same care as instrument sets. Regular staff training is essential every 6 months. There should be training SOPs. We can issue training SOPs for our customers on how they can be inspected. So look for dents, cracks, warp lids, check the gaskets, ensure latches close securely, never pop open. So that is really when you close the lids, they should make a nice, solid, robust click, and they shouldn't be potentially hanging open. And verify filter plates are intact and firmly attached. So a nice 1, 2, 3, 4 there for inspecting physical damage. Cleaning materials, so clean after each use with pH neutral detergent as per the IFU. Avoiding high alkaline or acidic cleaners damage because they will damage an anodized surface. It's a delicate surface, so they'll definitely get damaged. Inspect gaskets, lids, and filters after cleaning. Operationally, hinges, latches, and locks should work smoothly, and that's something you might need some maintenance on if you think these containers are being repeatedly cleaned and then put in autoclaves. Latches and locks could potentially get stiff, so some lubricant could, I'm sure, help with that, and that's something you could speak to your manufacturer about. The container must close properly without misalignment, so it should align properly. Obviously, in the example of the damaged edge of the container or the corner, that's not going to align properly. And seals and gaskets must be intact and effective. So if you're thinking from a procurement perspective, so this is taking it away from maybe the sterile services or the theatres, then you've got to consider the tray height and sorry, your current tray size and heights with each set. So what have you currently got? If you've got double DINs everywhere and there's big sets, then you're going to have to split those out. So that means you're going to need more DIN baskets. You're going to need potentially double the amount of containers that you thought you might need. So really think about that. Evaluate the filter type. But what are you comfortable with? As I mentioned, you've got long-term filters out there that are PTFE that are validated for longer cycles, but how do you control then and how do you know how many filters, how many cycles they've gone through? With a disposable, you dispose of it. Yes, it's a disposable piece of paper that it's obviously not ideal from a sustainability perspective, but you do have that reassurance that you have a new filter every single time. Again, this might be a similar challenge with the I mentioned the valve systems that will just stay in obviously in situ. They're not changed at all. So how are you going to monitor and make sure that they're within their parameters validated in terms of the cycles? So assess compatibility with tracking systems. Does your tracking system accommodate containers? Does it have any sort of special modules for containers? So these are all things, if you're going about to hand over money for containers, is this as an extra consideration for you? Calculate the life cycle cost versus the disposable wrap. They are not a magic box. As I mentioned, you won't be pulling rabbits out of them. They won't solve everything overnight for you. They are very, very good and very effective for particular situations, for particular hospitals that use them, and indeed some hospitals that are completely containerized that have capacity. So in summary, containers are ideal for large, complex surgical sets, and we actually got into containers first of all through hospitals that were looking to put their large orthopedic sets in them. And so ideal for heavier sets, which there may be a tear risk. They can reduce waste and cost. As I've mentioned, there's other considerations. High volume operating theatres and trauma centres, ideal for those, ideal for off sites, ideal for mobile surgical and field hospitals, and situations where wrap is commonly getting damaged. So is there a winner? We've given lots of, or I've given lots of different sides to both sides of the tins versus tray wraps. So from a micro barrier perspective, and I'm going to score this like a football match, like a soccer match. So it's 1-0 to tray wrap in terms of the just through my research and thoughts from my interviewee that they prefer to look at the integrity of a tray wrap and be able to see if there is a hole in it, whereas there is a bit of an unknown with a container. From a life cycle cost, containers go 1-1. Sustainability, containers at 2-1, as we know we're not disposing with, although we might be disposing with some of the plastic catches and some of the filters, we're not disposing with the volume of paper that we would be with tray wrap. Workflow efficiency, containers 3-1. From a maintenance burden perspective, tray wrap is the winner because obviously you have tray wrap, it's disposed of, whereas with the containers I've mentioned, it's really got to be treated like a surgical instrument, have that maintenance procedure and keep on top of that. And 3-3 washer throughput. This is obviously a vital point for hospitals who may wish to change over to tray wrap to containers. So take it, for example, we've got our surgeon who has been at a hospital previously that really likes containers and that's what they're used to, but doesn't realise that in the washroom they don't have space for an extra washer that they would need, or extra capacity that they would need to store the containers, but certainly extra washers, because obviously when you're washing containers, you've got to wash the container itself and you've got to wash the basket of instruments, so you're going to need that extra space. So an honourable draw, 3-3, containers versus tray wrap. So thank you for listening. This is my there's a QR code there for my email. Also to reference the Perdia sterilisation containers that Surgical Holdings have on the market, a very, very high quality product and is making its way throughout the UK. Okay, I'm going to stop sharing now and hopefully have a raft of questions for me. Let's have a look in the chat. So we've got a couple of questions coming in, and I'm going to try and answer some of these where I can. And please, if you have anything else coming up, please feel free to stick it on here. So the first one, just about how often containers should be replaced or tested. It's good that we've got some other questions coming in now, which are great, which I will also try and answer. So, sorry, right, I'm getting distracted. So how often should containers be replaced or tested? Well, I mean, as I mentioned, you've got a validation cycle with a container. So if for instance you have a container that's recommended for a certain amount of cycles, then you would look at replacing it after that period. Other than that, yes, of course, if a container has got some of the damage that we've seen in some of those photos, then you definitely need to be having that container replaced. If you've got lids damaged that have got chunks out of them or dents, then that should be replaced straight away. So you can't really look at it on a cyclical basis. You've got to assess with that maintenance and with that maintenance program, and obviously keep an eye on that. Um, Another question. So, does any of the research take into account the CO2 impact of aluminium and container manufacture and extra energy use for having to wash containers? Well, I can say that obviously I've read lots of different research across the putting this presentation together. Um, I think it depends on what angle the researchers come from. Of course, we know there's often bias here. There is, of course, an impact for manufacturing containers that are made from raw material. You're extracting that material from the ground and you're manufacturing those products. But if we're using the most efficient methods possible, obviously, then that is only a one-off on that particular spend, because you haven't got any ongoing cost other than the filters potentially. So that is something to consider. But I can look at that. I can look at that research and I'll see if any of those have that specific research in. I know definitely, as I mentioned, also extra information on the question there was about the extra energy for having to wash the containers. Well, that was an omission on the research. As I mentioned, this was that it was accepted that the research was given from the manufacturer of the container itself. So we really want to go in and look at that objectively. Are containers stackable? I believe that some are stackable, yes, and some may not. I would advise that you look at the IFU specifically. I'm happy to share our IFU on that so you get that information. Obviously, that is part of the benefit of the containers is the shape of them and that you have that uniform whereas you don't have that necessarily with tray wrap. But of course, generally, it's better off to put things in racks where you're not putting containers on top of each other. Of course, because you've also got to consider that you might damage the actual integrity of the anodizing. Someone's asked um, about the actual about the repair cost of containers. That would be something that depends on how damaged it is, I guess. If it's something that is like a gasket replacement, and that would be a fixed cost. But whoever's asked that question, and I don't know that everybody can see names on here, so I don't want to start saying people's names, but that's something that I'm happy to give advice on after the call. It's not always the case that containers can be repaired. In those instances with those photos, obviously they're extreme. You're not going to be able to replace those, or sorry, repair those. In terms of the efficacy, being able to test the efficacy of the seal should really be validated and repeated process. So yeah, I agree that is a challenge. How do we do that? How do we do that with tray wrap though? Can we do that on a repeatable basis? We can only do that with a container if we're doing something like the vacuum system that is testing the container itself. There's been an inquiry on one of the questions about the cost of that, and I'm happy to again share that information after the call or after the webinar. So another question about the anodization on the tray wrap, and obviously if the anodizing is damaged, then can this potentially contaminate the washer? Well, yeah, I mean, the anodizing itself as a medical device, part of manufacturing a medical device would be performing biocompatibility. So the actual surface of the container itself should be biocompatible in regards to being safe enough to manufacture that product. So yeah, if you're obviously part of that risk assessment, we'll be building in whether it's safe for those to go in and if they contaminate the washer. So that's something again that you would want to consult with the manufacturer on, and obviously if that is a risk. In terms of it being an impact to the patient, I know there's been There has been some activity around the white powder, and obviously when that occurs, if the anodizing is damaged for the container, and I believe that was deemed to be found not to be a patient safety issue. So again, that's something that I'm happy to pick up and investigate further with anybody who wishes. Please drop us a line after, and we can discuss that. Okay. If there's anything else specifically on the Q&A, no, just on the chat. So anything I've missed here? Please, any other questions? Please fire anything over. I've got my colleague Mark on the call here as well. Who, Mark, I don't know if anything's come up. Please feel free to jump on and say if anything anything you further that you feel is relevant. So another. Oh, there he is. So another comment just quickly said a hole or tear in a tray wrap is much easier to see than damage to a seal. Certainly at theatre level, yeah, I think that's something that my interviewee also felt that they could see that, whereas without the certainty of maybe the testing or the regular testing of containers, that is an uncertainty. So yeah, that is difficult to argue with, of course. Although I guess you could get a really small tear that can't be picked up. So Mark, was there a point you wanted to mention there, or anything you felt's worth developing?
No, I think you've covered everything there. Thank you.
Okay, excellent. A further comment there. Somebody said, having used both the tins and the wrap, they've got to agree with these points. Just around, I guess, the challenges for the in situ validation. So yeah. And what we got here, there's another question's come up, so I'm just missing these as they come in. So is the machine shown during the presentation, is it suitable to be used in the clean room and extraction point? Yeah, I believe it is. This is something we've just put one in recently in a hospital, so happy to have a direct conversation in that, and indeed the hospital themselves, I'm sure, would be happy to have that discussion, which is probably a much more powerful thing than me telling you about it. So yeah, please reach out and we can discuss that. One comment here, just finally, what is the full life cycle carbon footprint of an aluminium container compared with tray wrap, including manufacturing? Offhand, I haven't got that information. I'll have a look at some of the references and share the references. In actual fact, I think in my final slide I didn't show I had all of the bibliography, so I'll share that. There have been life cycle assessments done on containers, and obviously there's, as I've mentioned, it's there's pros and cons to both sides. So where are we now time wise? So just give another couple of minutes in case there are any other questions, and please feel free to send me in directly, or the chat will probably still be live after the presentation. So you can obviously stick anything on there, and I'll share this presentation after. So if there's anything else comes up, so okay, great. Well, doesn't look like there's anything else come through there, so I will conclude the event. Thank you everybody for your attendance. Really appreciate it. Any feedback, please send over. Because obviously we want to develop more of these and more webinars. We have currently a webinar on flexi scopes, rigid scopes, surgical instruments, but we want to develop that further and make it suitable for you guys, obviously, because obviously that's who is the key point to make useful education for you. So thank you everybody, and have a great rest of your day. Bye.